Let's factor the polynomial completely. If the polynomial is prime, say so. Here we have a fairly complicated polynomial in 9x to the 6th, y to the 4th, plus 12x to the 3rd, y squared, plus 4. I don't see any greatest common factor to factor out. So let's begin to treat this as we would any other trinomial. But I want us to closely inspect our first and last terms. As we look at this first term, let's notice that it's a perfect square term. That 9 comes from a 3 times 3. The x to the 6th comes from x to the 3rd times x to the 3rd. And y to the 4th comes from y squared times y squared. So if we take 3x to the 3rd, y squared, and square it, we'll get that first term. As we inspect this last term, 4, we can see that it is a perfect square as well. It is the quantity 2 squared. Now let's see if our middle terms match up to fit our perfect square trinomial format. Our end terms fit. Let's check the middle. Can we get that middle term by multiplying 2 times our first term, 3x to the 3rd, y squared, times our last value of 2. 2 times 3 is 6, times 2 is 12. We've got our x to the 3rd and y squared values, so yes, indeed, it does match up. This is indeed a perfect square trinomial. The factorization form for this perfect square trinomial is going to fit this format or formula. A squared plus 2ab plus b squared will factor as a plus b quantity squared. In our polynomial, a is represented by the quantity 3x to the 3rd y squared. B will be represented by the value 2. Let's plug those values in. In for A, 3x to the 3rd y squared. In for B, we put that 2, and this term gets squared. As a check, we can square that, FOIL this out to ensure that we do indeed get our original polynomial. I think we will then find that the correct completely factored form of 9x to the 6th, y to the 4th, plus 12x to the 3rd y squared, plus 4 is indeed 3x to the 3rd y squared, plus 2, quantity squared.